Situation awareness-based smart contract for modular construction. Hello, I'm Huaming from MCC Group with Mr. Gongfan, Professor Liu Min, Professor Simon, and Mr. Esther. COVID-19 pandemic heavily struck the construction industry globally. Manpower suffers from shortage due to quarantine measures and restrictions. Material price fluctuates with the waves of the COVID. Productivity becomes lower due to social distance and less or lack of trades. During the COVID-19 new normal, modular construction is a solution that shortens schedule and reduces cost through offset prefabricated modular. The PBU prefabricated bathroom unit is popular in Singapore. The advantage is reducing the number of specialty trades and the volume of materials arriving on site. The disadvantage is showing weakness in the supply chain. There are three challenges in the modular construction. The first is tracking and tracing project progress. The second is coordinating interruption in task handles. The last is motivating reliable work plan commitment of specialty trades. Our research objectives are investigating the PBU delivery reliability's impact on on-site installation productivity through computer simulation, and establishing a situation awareness smart contract to motivate reliable prefabricated construction material delivery. These photos are PBU in Singapore, before and after installation. PBU productivity improved up to 60% manpower and time savings, and environmental friendly, less noise, dust, and carbon consumption. These photos are beam models versus real PBU on construction site. The first row is PBU model on shape, on site, and hoisting up. The second row is real PBU on construction site. Actually, most construction sites in Singapore are congested. It's quite difficult to maintain a large stock of PBU inventories, and therefore, many firms have adopted the JIT in terms of minimum and maximum limit for the PBU stock. Just-in-sequence is one of the most challenging applications of the PBU JIT and in continuous evolution. For example, in Q project, the master program delayed by PBU delivery delay, and in A and N project, the project cost increased caused by additional PBU offset storage. To meet the PBU just-in-sequence JIT, it involved not only the PBU factory, but also the design consultant, the logistics supplier, and the site PBU installation subcontractors. The longer the PBU fabrication cycle and the shipping distance, the higher the probability that unforeseeable circumstances will disrupt the process chain. The contract manager, project manager, and the engineer are suffering the daily tracking, the variety and the responsiveness of PBU supply chain, update the PBU installation status, and the coordination with parties. To motivate reliable supply, attention in time with supplier quantitative incentive is useful.
Hello, this is Gongfan Chen. So next I'm gonna talk about how we use the blockchain smart contract to help the modular construction project. So blockchain is essentially a continuously growing list of the records called blocks, which are linked and secured using cryptography. And a smart contract is a set of computer codes defining the responsibility and the risks between two or more parties. The discussion of the blockchain and the smart contract application in the construction industry started recently. Some of the ideas include supply chain management, using beam Friday cost model to trigger the progress payment, synchronizing beam operation in the blockchain, using reality capture technology to automate the smart contract payment, and incorporating digital twin data into the blockchain. One of the common shortage is that most research fail to use the real-world data to validate their research ideas. Therefore, this research is going to provide a smart contract prototype to illustrate how we can implement it practically. This research will use the modular construction data to establish a simulation model. Different levels of PBU delivery variability were defined to investigate the impacts on the project performance. We will select the benchmark and compare each scenario with the benchmark. If there are costs saved for advantage scenario, we will reward the supplier. Otherwise, we will penalize the PBU supplier. Later on, we will program different scenarios and corresponding payments in the Ethereum smart contract to motivate a higher delivery reliability. When the GC checks the performance and the input detected scenario, it will trigger the smart contract, and smart contract will assign the rewards or penalties to PBU supplier automatically. Here shows the simulation flowchart. The main sequence are PBU arrival, install loading platform, lift the PBU, and install PBU. We will simulate this process for one building. We implemented our simulation in the Strabo scope. We changed the PBU delivery variability to investigate the impacts on the project overall performance. In the ideal situation, we want a supplier delivers equal types of the PBU, which is 6 PBU-A, 6 PBU-B, and 6 PBU-C per batch. We calculate the deviation based on this. Two examples are shown here. The variability level can be varied from 0 to 24. We class them into 5 different scenarios in the simulation. The initial results show that when the variability is less than 12, it can guarantee a relative smooth execution of the project because the project duration is around 40 days. And when the variability is greater than 12, the project will suffer from great impacts because of the unavailability of specific type of the PBUs. The effects are getting severe when the deviation increases. So in the worst case, the project duration is around 50 days. And then we can calculate the cost differences for each scenario and use it as rewards or penalties to motivate the reliable PBU delivery in the smart contract. The project manager recommended to use scenario 2 as benchmark because PBU reliable delivery is vital for project success. It is challenging to tolerate a relatively low reliability benchmark. Here shows the smart contract algorithm. Essentially, the input of the smart contract will be the variability level, and the output of the smart contract will be automatic rewards or penalties. Right now, we are trying to validate if the smart contract functions as what we have designed. So the GC can deploy the contract by entering a GC and the PBU supplier's account address. He can randomly activate the contract with 5 Ether. It will return a successful mark if the input information was correct. Assuming GC detected there are only 2 runs in the batch for PBU delivery, which indicate it belongs to the scenario 1. So GC input variability level 1 and click on transact. Then the rewards will be assigned to the PBU suppliers automatically. We can check the PBU supplier's balance. So 1.74 Ether will automatically add it to the PBU supplier's address. And all the transaction information will be synchronized and distributed in a shared network. The smart contract will reject the transactions and return an error mark if any information fails to comply with the contract clauses. For example, if the PBU delivery variability was 5 were detected, which required the PBU supplier to pay 19.98 Ether, the contract only allowed the PBU supplier to pay the contract using the penalty function. If the PBU supplier only paid 2 Ether to the contract, then a video signal will return. And all the decentralized network users can find out the PBU supplier was trying to fake the smart contract. So in conclusion, simulation transforms the implicit knowledge into explicit knowledge, which provides concrete clauses to establish the smart contract. And the smart contract can execute itself accurately to motivate higher reliability through automatic rewards and penalties. In this research, our contribution is that we establish a simulation model to understand the impact for various levels of delivery reliability to installation productivity. And second, we develop an incentive penalty smart contract prototype to promote reliable delivery of suppliers based on the customized needs. The limitation of the research are the workflow reliability of the installation productivity were influenced by other specialty contractors which are not considered in the simulation. And then the blockchain platform or interface should be further constructed to explain the transparent information that were recorded when interacting with the smart contract. That's the end of the presentation. Thank you very much.